Hi everyone. We will be starting very soon. I'm just preparing some streaming facilities with YouTube. Just let me start.
Hello, good morning.
Morning everyone.
Hello.
Hello. Hello, Alessandra. Nice to see you here.
Hello, it's a pleasure.
Yes.
We love video. So
Okay, just in case I started streaming on YouTube, just in case some of our social media subscribers would like to connect, I asked Olga to post that. Okay, and then we will be starting in a couple of minutes. So we will let people to join. Okay, we are missing quite a few people. So I propose we will wait a couple minutes. Okay, so people are coming. Okay. Right, so yeah. Okay, so are we ready? So we have Dragos are here, Wissam is here, Eduard is here, so all the presenters should be here. Yes, I will be recording a meeting, and also it's available, will be available on YouTube right away because we have a streaming just in case like you want to like share that with the social media. Yeah, why not? We can post a link for that. Okay, so it's 9:01 in Europe, and we may start. Let me start recording. Hello, everyone. Let me share my screen. I will start with a presentation of the VeriDevOps project and the goals for this workshop. And then we will present very briefly some recent, let's say, findings from our projects. With the goal actually to engage some discussions with you and like plan some joint activities if you have some. And also, I mean, all the feedbacks and comments will be quite nice to have from your side. Right, so let me start screen sharing. And right, so I hope you can see my screen now. Okay, just putting that here. Okay. Right. So this workshop is like funded and sponsored by VeriDevOps project. My name is Andrei Sadovich, and I'm technical coordinator of this project. The project involves several companies, including Malerdalen University, the main coordinator of this project. Then Softeam France as a technical coordinator and provider for modeling tools, ABA Academy University, Ikerlan, Imontimaj, and our case study partners, Fagor and ABB. Right. The goal for this particular meeting will be to get to know each other. So we submitted a lot of invitations. And since we are dealing with subjects such as requirements engineering, security requirements engineering, testing, protection, vulnerability scanning, so we would like to connect with you. So with all the projects and researchers who work in similar domains, so that we can establish a dialogue and plan for joint research activities. So a spoiler, we are planning to publish a book within 1 hour. And so this workshop is a kind of appetizer to have a dialogue to kind of spot who would be interested to contribute to this book. And so we will be happy to share with you 1 year of work on the book. So agenda for today. So we planned like a small home event, let's say, with some small introduction of the objectives of the VeriDevOps project. Then we will be shortly covering state of the art, let's say, so some like dedicated to VeriDevOps project, but covering like touching upon the topics like NLP, security requirements patterns, reactive protection at operations, proactive preventions at development, and then we would like to wrap up and have some shorter discussion. So this is actually home event, internal event, let's say, so that when you can, in my presentations, you can actually stop me at any moment and ask me a few questions. And I will be happy to help you if I can. And also, based on the topics, we can set up some side meetings with you, so we can discuss what your progress can be. Do something, change data sets, for example, or like share some results and methods that we use for various things. So yeah, that's it. So it is home event, so be set up like comfortably, and like we kindly invite you to ask questions when you want. So one thing yeah, recording was started. I'm sorry, guys. Yes, it's recorded in the cloud, so no problem, no problem, and it's also light. No, it's sorry. Okay, I will check recording. The recording is started, so just in case you want to know, so it will be available at some point on YouTube, but also it's live streamed to YouTube, so live streaming will be also available on YouTube. No worries. So I see some questions in the chat, so that's okay. Also, in terms of participation, so since we are so many in this chat, 28 people, so I would ask you to raise hand. There is a possibility to raise hand when you want to ask a question. So I mean, that way we can all participate. Okay, and if you have some trouble, just push some message in the chat. So I see the chat, and so I can stop, and I mean we can discuss something. Okay. So I think that was it for this first, let's say, welcome speech. we have a lot of people. So we at some point it would be good we have some kind of round table, right, to present everyone and all the interest. But unfortunately, I would say that if we are short in time, we won't be able to do so. So probably when you ask questions, you can present yourself very quickly, and then we can continue to talk. Right. Okay. So let's start with the introduction. Some motivation for our project is that we see that currently the number of vulnerabilities, security vulnerabilities, has grown dramatically and actually raises very, very fast. And I mean, from 2012, we like reported more than like twice as many vulnerabilities as in 2012, right? So and I mean it's getting high, and I mean it will be growing higher and higher. So security or software security will be quite important topic for many years from now. So what we also see that, I mean, all sectors of economy are affected by that, including mostly energy sector, but also like transportation systems, food and agriculture, commercial facilities, critical manufacturing. And so in our projects, we have actually partners, case study partners that are in this domain, like transportation, critical manufacturing. So for them, the security and dealing with vulnerabilities is some of the very important topic nowadays. Right. So another um, um, point why it's very important to deal with software vulnerabilities is that, I mean, even though like majority of vulnerabilities reported are network vulnerabilities, 20% are application vulnerabilities, and among those 19%, the proportion of the critical risks is quite high. So also, as it was reported, like 80% of system had at least one vulnerability, 70 had more than one vulnerability. And interestingly, 1 of 5 system has 10 and more vulnerabilities for the system. So vulnerability is not necessarily an exploitable way to crush your system, but it is quite a risk that on some day somebody will find a way to exploit this vulnerability. Another thing that should be mentioned, that the time to deal with vulnerabilities is rather huge. So here's some chart that shows like a model, like a risk level and timing. And so we see that at some point the security vulnerability is discovered, so the risk getting high, then it get known by the community, and yeah, and risk gets even higher. Then at some point vendor gets knows that this vulnerability exists, right, and needs to do something to patch it and publish patch, and then all the users have to patch their system and so on and so forth. And so, I mean, this time is actually quite huge, right? And during this time, there is a risk that somebody would exploit this vulnerability, do some harm to the system, right? Or like company's data, organizational data. Okay, so some more statistics and some more reports. So as we saw, number of vulnerabilities has grown dramatically since 2002, right? By several thousands a year. Then, when interestingly, So average time for organization to close discovered vulnerability is 67 days. So when I say long time, it can go actually up to 67 days, like more than 2 months, okay, to patch vulnerability. So about 40% of organizations then don't even scan for vulnerabilities. So they even don't know if they have any vulnerabilities. And so that's actually quite dramatic. About 60% run legacy systems, like for example, Windows 7, which is not patched, and it's too expensive to replace them in near future. Okay, so I mean, it means that those vulnerabilities represent a huge risk for these organizations. So what we can note is that there are, I mean, 50% of companies say that they have actually quite a hard time manually navigating through various processes than kind of actually patching vulnerabilities. So they, like 60% of teams, so they feel disadvantaged because of manual process for applying patches and like finding those vulnerabilities. And so, I mean, 5%, nearly 2/3, say that it's difficult to decide correctly what is the level of software patch that needs to be installed. So this gives us a huge motivation to automate various processes and provide methods and tools to deal with security vulnerabilities in a faster manner. So, so just to recap the challenges, we have tons of security vulnerabilities. They are omnipresent, and the number of these vulnerabilities will grow dramatically. So with internet, with cars, railways, industry 4.0, and so those all connected internet devices that we each year we have more and more. So the number of security scenarios, like potential attacks and exploits, explodes, right? Those vulnerabilities can cause economical losses, but also can affect the safety of operations for example, for industrial system. Also, what we know from the literature that and practice, that security mechanism has to be built and reinforced from the beginning of a life cycle. So, and it is quite difficult to retrofit security back into the design, right? Also, I mean, nowadays, many companies, I would also claim that most of the companies use CI/CD processes with continuous integration and continuous deployment, which means that all these prevention protection mechanism should actually cope with these fast cycles of like development, integration, deployment, right? And so these kind of fast cycles of adding new features, testing them, deploying them, getting feedback, all these processes has to deal with security as well. And so this is something that we would like to deal with. Right, to recap, okay, on one end, at the left, we have repositories for vulnerabilities, for attack vectors. So then we have some requirements, implicit or explicit, from the standards or from the customers, that needs to be addressed at development and operations for the systems. And so nowadays, this process is mostly manual, right? And so what we would like to do is to automate that as much as possible and enhance that with more tools, more methods. For that, we got actually quite a good intuition that some formal specification formal security modeling, and a lot of generation tools can actually help. So just imagine if we have formal specification in the middle of our process, we can configure monitoring tools, rule-based monitoring tools. We can generate automated tests, provide design checking, right? And so, I mean, there is lots of benefits of having some formality in terms of security requirements and in terms of specifying vulnerabilities in a formal way, right? However, as probably most of us know, is that there is a huge difficulty to specify formally anything because it requires lots of manual work. So what we want to do is actually to enhance the process getting from textual information and textual requirements, the description of vulnerabilities, standards, or kind of customer scenarios into some formal specification security requirements from which we would like to generate as many as possible the various artifacts that would allow us to configure vulnerability scanners, rule-based monitoring, automated anomaly detection tools, root cause analysis tools, but also help in automated testing, design checking, and that's all has to be enabled and compatible with continuous integration, continuous delivery processes that nowadays in modern development are quite quite popular, and I mean, and that tend to be very much used in the industry. Right. Okay. And so for that, we had a few solutions that we target. So on formalization and for specification of like security requirements in a formal way, we had ideas on extracting those requirements from some unstructured text or textual documents, right? To understand what is the requirement, what is not a requirement, what a security requirement, to which category of security requirements it belongs, and whether there are entities that we can extract from the sentences so that we can initialize various patterns for formal security requirements. So as a result, we would like to obtain some formal specification that we can use in other steps, like can we use that for model checking, right? To first check whether security requirements are good or not, and I mean, check their consistency, for example. Can we subject use that to check design models if you have some? Can we use that for test generation and also in fighting with the Oracle problem for the testing? And so that should be the topics that would be interesting to us in our project. In terms of security monitoring and at runtime, so we would like to progressively observe and inspect the system, network, traces, and check whether we have some anomalies that may indicate any vulnerability or prevent some attacks, right? And root cause analysis. So we would like to know what is the root cause for specific alert. So, and that will be done also through similarity learnings, so that we can provide accurate recommendations about what needs to be done. Right. So to recap, the mission of the project to provide research in these various areas. So we have a consortium of the companies and research teams that deal, like provide research in these areas, right? And we would like to significantly improve the level of automation in dealing with vulnerabilities, both at runtime, operational level, and development level. We have set up a certain number of objectives for the projects and KPIs. All right. With the goal to improve, like decrease number of days needed to fix vulnerabilities, to process the textual information and getting that into formal specifications. Also, in terms of testing, security requirements, and also integration into current DevOps practices, and validation that through industrial scenarios with our partners such as ABB and Fagor. Right. So expect results. So what we expect to obtain at the end of the project, we would like to obtain methodological results, also several tool sets, right? Like several data sets for a training system to recognize requirements. Also, specific catalogs of security requirements patterns, threat oracle engine that would gather information about system and check whether it's vulnerable to some specific known vulnerability. Monitoring, root cause analysis toolkits, resilience catalogs, those things that we would like to provide and like to the companies and to the community. Right, at the end, we would like to have an integrated framework that would link all together those results that should be validated by demonstrators by the industrial companies such as ABB and Fagor. Right. Based on that, we planned our project with various work packages that follow the structure of this concept. So also we planned our project for 36 months, and we are currently at months in the very beginning of the project when we gathered some requirements from the end users, ABB and Fagor, but also we worked on checking and gathering the state of the art for the area in those domains that I previously covered, so that we can compare our results with a baseline, let's say, and identify the most interesting ways where to go. So, starting from this moment, we will be doing more prototyping work, more experiments with in the case studies, and at some moments like in June, in January, and so on, we will be delivering some more results, and we will plan some more demonstrations that we can show you. Right now, so we are ending this important first milestone, and we are happy to share few results with you. So that would be it for this recap presentation, right? We have a couple of minutes for questions if you have some. Otherwise, we will go directly into more like, let's say, like research-oriented part of the workshop. Any questions so far? You can raise a hand or type something in the chat. So otherwise, I think we can move to other presentation. So just Just a second. Just a second. Okay. So before, okay, let me.
Andrei, I have a question.
Okay, please, Nikolai.
Well, maybe it will become clear later, but well, do you think that some methodologies will be valuable not only for security applications, but will have more general value or something like this? Or do you
Yeah.
think that the project is very, very much topic dependent?
I guess I would not say so. It's very much security dependent. So, for example, testing techniques like model-based testing or testing generation would be definitely useful for other domains. Also, some of our requirements have to deal with safety, and security is actually linked to everything. So everything that can bridge the system, including like safety, would be considered security one at some point. So yeah, so we'll have a lot of things. Also, in terms of NLP, okay, we map things to patterns for security, but it can be other patterns for formal specification for timing, for example, or something else, right? So also in terms of extraction of requirements from textual documents, it actually can be useful in many other domains because, I mean, the way we do that is, I mean, it can be fine-tuned for any domain. Like, okay, so to get you to give you some appetizer for this automated generation of security requirements, here is a kind of a small prototype of one of our students, right? And so it takes as input some specification. I have a specification here that I just found. Sorry, I found in internet. Okay, just a second. Here you go. So there is some kind of requirements document specification. There is also some security requirement inside. Okay, so what we will do, I will open this document with a prototype. Okay, so it start working. Okay, and it gets some results that might be interesting. For example, here the prototype identified few sentences that may be related to security, and the first one is actually definitely like specify the factor that will protect software from accidental malicious access, misuse, and modifications. And if we go back to the document, right? Sorry. If you go back to the document, it actually effectively the part of the document that talks about security. Okay. So, I mean, this is kind of small prototype by a student, so we'll definitely have something more robust. But you can actually imagine how this guy can actually work. So we have some documents, right? And the prototype trained prototype can extract various security-related requirements. So this one is not particularly clever. It also finds something that is not really requirement, but it's actually the first try. And I will discuss with you some implications of that. Okay, let me then start discussing a few of our findings. To recap, so we are going to talk about getting from security requirements like using NLP and using some formal specification, some formality. Christina, you wanted to ask something?
Yes, thank you, Andre. Just a short question. While this is very useful, isn't it a bit dangerous to extract, to take these requirements out of context? I'm saying that when you process a document, it's important to understand the context also in order, especially if you go further to formalization.
Good.
And the relationship between some requirements is very important, the dependency.
Sure, sure.
So extracting this and presenting that as standalone requirements might actually affect your steps further.
Yeah, I mean, it's currently a research topic for us as well. So because, I mean, of course, it's very much context related. And in our like training data sets, we would like also to not only like have a sentences, but also everything that around those sentences that might explain the context. Because sometimes, I mean, specialists use abbreviations, or they just kind of have kind of semantical links to previous phrases and stuff. So they may be kind of good paragraph describing anything, and then short phrases describing requirements. So yes, of course, context is very much important. Honestly, we don't know how to deal with that for a moment, but we imagine that this will not be kind of just extraction of the sentence, but it will be kind of sentence highlight within the document where you can like navigate.
Yeah, exactly. Maybe it's just a pointer to something. Yeah.
Yes, okay. It's kind of a pointer where you should look at, because what we also look see that those security requirements can spread over the document, not necessarily being in one place that's called security requirements. Also, in terms of categorization, classification, so something that relates to access, like securing access to specific data, may also, I mean, be connected to the data integrity, for example, right? And so classification not necessarily correctly reflected in the document, right?
Yeah.
So, and when you want to really deal with the like data integrity, you might actually need to look to other places. So that way, we can actually provide some kind of automated classification of the requirements. Which is quite nice, I would say, for the specialists.
Yes, absolutely.
Right. So
thank you.
Yeah, yes. Thank you for the question, Christina. Okay, so what we discovered so far, first, like to give you smaller like concept what security requirements. Like in literature, we find that security requirements deals with specific, like with threats. So it relates to eliminating particular threats that might be gaining access, unauthorized access to the system, or data integrity breach. Escalation of privileges, right? So security requirements is to protect specific assets that may be personal information or specific critical things like I don't know, a credit card number or users' photos, for example, or it can be industrial systems possibility to break particular hardware, for example, with a misuse, right? So then as security requirements, it should be linked to specific countermeasures. So we actually think that security requirements, so description of that plus countermeasure, is the formal specification of the requirement. So, and countermeasure could be security mechanism or security constraint or specific restriction. So, important, I would say that security requirement and countermeasure, they are quite heavily linked. we can go to extreme and say that a countermeasure would be this security requirement, let's say. So from sometime, yeah. So as the best definition for the requirement would be a test that would prove that requirements is fulfilled or not fulfilled. Right. So what we found for NLP for requirements engineering, actually there is a huge area of research for like decades, right? So we were particularly focused on recent advanced with machine learning for requirements engineering. So there were actually quite a lot of things done there. And one of the most interesting one for us is classification task with machine learning that helps to predict category of particular text. So that actually quite helpful when we want to know whether a text is requirement or not requirement, right? Whether this text is security requirement or not security requirement. It may be multi-class classification saying, is this requirement is about access control or about availability, for example, or data. So classification and machine learning techniques for that are quite interesting. Then there is something called extraction, but it's extraction in terms of you have a sentence and you want to get out some specific terms, right, from the requirements text to build up some project glossaries, but it actually can be used to fill information, like extract information and fill information in specific patterns. For example, if you have a patterns for the formal models, extraction methods may be interesting to use there. Then clustering, organizing documents into specific subsets or clusters. Another thing that we found that was used with NLP is detection. So figuring out what is ambiguous in the requirements, okay? So to like with the goal to make them correct, more coherent, right? So it goes into detection of lexical issue or like usage of grammar rules. So some vague phrases or weak verbs, right? Some syntactical ambiguities. Yeah, if whether requirement follows specific predefined template or recognizing some equivalent requirements. So that's actually be done with some detection methods. We actually also checked some interesting domains such as vulnerability detection, right? So there is ways to statically analyze the software with machine learning techniques, and checking whether vulnerability is present there. Also interesting domain. So the people were scanning lots of software repositories to find out some automated way to repair vulnerabilities. So to find out the kind of vulnerability software patch. And so learning from source examples, if they can be prediction for kind of automated patch for certain software. Another thing is specification analysis. So it deals with security risks on the specification level. It can actually deal with descriptions of vulnerabilities in textual format and assess security risks for the systems. So in terms of evaluation, it's important to mention a few things. First, in ML, machine learning, they use quite a lot metrics like precision, recall. If you take the problem of like extracting requirements, like from the text, so identifying what is a requirement, what is not in the text, So precision would be number, like proportion of correctly identified requirements. So we have a set of phrases or sentences that the algorithms, the model algorithm says that it is requirement. So, and what is really a requirement in this set, comparing to the whole set, would be the precision. Okay. Recall, on the contrary, is a bit of like proxy to understand how many requirements we missed. Okay, we detected this much of this many of requirement, but there are something that rest at the rest of the document. So how many of those we are missed? So if we high on precision and high on recall, we are good. And often authors compare the algorithms and give some numbers in terms of F1, which is actually combination of precision and recall. You can consider that as a kind of average, right? That gives us some kind of ranking. Very important in this all machine learning techniques is the data set that been used and the training mechanisms. So, I mean, how the data set was split for the training. So there are some like authors, like in many cases, for example, we take a set of documents, we take one document, we train on like 90% of the document phrases, and on the 10%, we actually do our evaluation. So, and we take another one and another one and so on and so forth. That, to our understanding, is a bit of, let's say, not usually how the industry works. So what is expected in the industry is that you have train model, you take a new document, you try out and you see whether your algorithm is working good. So you have a set of trained documents, and then, I mean, with the new one, so you have your model is transferable to new domains, new documents. That's what we would expect from the industry. Right, and that's not necessarily the case for the methods. In terms of deep learning, so there are some classical techniques, like, for example, convolution filters, convolution neural networks, and they be used to classify requirements, like to understand whether there is a requirements or not, and they obtained the ranking like 80%. So they could actually identify in 70% of requirements, right? And they are missed not so many requirements with the algorithms. Then the similar technique is actually used to identify security requirements in a set of requirements, right? And with a kind of high ranking, so about like 90%, so which is actually quite good. Recently, but there are actually some limitation to this approach with the feature modeling. So training the model is actually quite difficult for that. So what is currently used is something that called transfer learning methods. So that actually something quite interesting. So the first paper on that was published around 2018, and the research coming from Google, what people did, they actually trained the model to understand the language. So on huge set of like English literature, right? So all the text sources in English literature, let's say that this way. So you have a model that understands somehow English language, right? And to train that for specific tasks like classification or extraction of requirements or specific particular texts, the only thing that you need to do is to adjust specific filters and fine-tune the model. And so your training data set, giving that big model, your training data set is much smaller, right? And this gives you a huge advantage. So with a kind of smaller data set, you can actually obtain very nice tools. So that's been done for non-functional requirements. And the authors obtained quite interesting results with ranking about 90%, which is quite good result. Right. So, I mean, we actually have like quite a good document about that we are also would like to have as a chapter in this upcoming book, right? When you see these references, these are references from this document that will be also publicly available in coming days. If it's not yet available, I need to confirm that. Another topic that is interesting in this with regard of NLP and machine learning and NLP is the availability of data sets, because I mean our innovation is only possible if we have data sets. No data sets, no machine learning. Okay, and so in our review of the literature, we were particularly looking into data sets. So we found actually quite few. Okay, so quite a list of data sets available, publicly available. The most known one would be the pure data sets. It contains public requirement documents, about 80 available documents. Some of them are labeled. Some of them even contain JSON files. However, we discovered that this labeling is not particularly good for us, actually. And actually, our current work is actually we have to relabel most of those sources, meaning that we need to extract from the documents precise phrases for requirements, and we need to understand whether it's requirement or not requirement, whether it's security requirement or not security requirement, and to which class of security requirements it belongs. So it's quite tedious work, but hopefully we'll have a clean and polished data set that we can also share with the community. Right, so pure data set, another one which is nice is promise data set, but it is actually quite small. Pure one is about 10,000 sentences. Promise is 600. SecRec is around 500 requirements. Then we have very nice data set on open source projects. So the data set extracted from repositories of open source project. And that's actually quite interesting as a kind of technique how to obtain the data sets. Another kind of data set from healthcare domain. So if you're working on healthcare and in healthcare, IT for healthcare, and you would like to build system for that, so you may have a look there. So then there are more data sets that we haven't analyzed yet, but that presumably contains quite a lot of sentences with some labeling, but we still need to kind of polish, understand whether how that can be used for training. So to that, it actually was an important step for us to look for these data sets and get get them and kind of make them operational. Right. Okay, so getting from NLP, as you may remember, we have the task for formalization. And with that, we actually had strong opinion, let's say, that we need not only deal with textual information, but also with means for verification. So requirement for us would be specification of this requirement, but also the means to verify that this requirement is fulfilled. Also, what we wanted to look at is possibility to reuse or kind of automatically instantiate the requirement. So, so we were looking particularly in this area, in this work. So, and actually we found quite a bunch of things. So there is an area when like authors, researchers looked into formalization with unified modeling language and linear temporal logic constraints, specific activity, using activity diagrams for modeling attacks or sequence charts, using CAPEC, which is attack patterns, to link them with vulnerabilities. So this is actually quite interesting part, this NLP that helps to make connection between vulnerability and attack vector. So which actually quite useful, because if you consider this couple, like vulnerability, attack vector, you may, it's exactly what we need. We need specification, we need verification mean. So vulnerability description plus attack is actually something interesting. Then there is quite interesting study about using Stride. Stride is a threat model by Microsoft with a couple of categories, and the authors, they link those threats to attack patterns, which is exactly what we need. We need a couple. Specification of the vulnerability and possible attack. So that's what we'd like to prevent. Another one, use cases and attack patterns. Okay. Then various work on generalization of attack patterns and implementation them as a kind of executable like patterns, like tests, executable tests, let's say. And so that's actually all quite interesting as a way to get from textual information like vulnerability into description of attacks, or like linking that to attack patterns, and then having them as some reusable tests, right, that you can instantiate for your particular system. That's actually quite interesting. So we also found a couple of ready-to-use catalogs for patterns, like temporal patterns, okay, quite known common attack pattern enumeration classification, CAPEC repository, but also there are some analysis and testing, validation and verification patterns that is actually quite useful, because our goal to make those to have our own catalog of those patterns, or kind of extend those catalogs of patterns with security patterns that should be instantiable, so and reusable, right? So our current idea is to look at parameterized unit tests as a kind of formalism to express the attack pattern. So we have textual information and we have test, like parameterizable unit test, as a kind of way to verify this, express this this particular security requirement. So this is kind of our ideas so far. In terms of gaps, so what, looking in data sets, we saw that, okay, they're not particularly clean. So we need working with a larger and cleaner data sets, we can obtain better results. We would like further experiment with transfer learning methods like BERT. In terms of security patterns, we would like more go into domain of attack-based patterns, right? And mapping requirements, vulnerabilities to attacks. And then encoding those patterns as object-oriented reusable templates. Right. I think we have. I have run out of my time. We have a couple of minutes, or we can actually establish a break. We can make a break for 5 minutes. Yeah. So just a small small thing. So what we did so far, we have relabeled pure data set and found 6,000 security, non-security requirements. More things our students did was binary classification, so security, not security for 2,000 sentences. And currently other team works on multi-class categorization of requirements. Recently, we submitted a paper where we tried to extract requirements from the text, and we compared with baseline methods and obtained, like with a small experiment, we obtained around 86% of F1 score. In terms of precision, quite high precision in terms of requirements found in the text. However, in this particular experiment, set of experiments, like recall, like missed requirements was not that good actually. But still quite promising results, I would say. Okay, with that, I think we can have 5 minutes break. And yeah, I will stay here. So we can have some discussions during this break if you have some more questions. Okay, any questions?
5 minutes?
Yes, yeah,
Okay.
it's a 5 minutes break, yes. So, and I will stay here in case somebody doesn't need the break but have questions. So prefer intellectual break, let's say. Okay, so who will be the next? Wissam, you are going to present? Or this will be Zohani or Eduard?
Sorry, what was the question?
The question is who is presenting next? Because I think
it's Wissam and Rosa.
Wissam, Wissam and Rosa.
Because
Okay.
War Package 3 should. And then
okay.
Tanvir and I can present.
Okay,
I think.
good.
Yes,
Good.
will be Wissam.
Okay, very good. Okay. Yeah, I will go to check if we have any questions on social media so far. Okay.
By the way, the YouTube stream looks good.
Yes, it's good one, but no questions so far, so it's okay. It's okay.
Andrei, I'll start sharing my screen for
yes,
Package 3.
please. Okay, let's please. I can then stop sharing. Okay. Okay, I guess we can start, Wissam.
Yeah, yes, sure. So my name is Wissam Alouli. I'm working for a small company located in Paris called Montimage, and I will do this presentation with my colleague Rosa Iglesias from Ikerlan, Spain. So it deals with the reactive protection and at the operation. So as you can see here, the whole concept of the project, and we are working in work package 3 of the project that deals with the reactive protection mechanism developed in VeriDevOps and applied during the operation. The main objective of this work package is to perform continuous risk assessment of a running system in order to determine a list of potential vulnerabilities, threats, and potential countermeasures that need to be applied to enforce security at runtime. So as you can see, we start in general by identifying the list of potential vulnerabilities that can exist in a running system, and we also try to detect potential security incidents or some anomaly in our system, and based on this incident that try to exploit the vulnerabilities, we will try to determine their origin. That's why we apply some root cause analysis that will help us to select the best countermeasure and corrective action that need to be performed to mitigate the risk in the running system. In fact, we start in VeriDevOps by this operational part, because we consider that we have running system already that are already deployed, and we would like to reinforce their security at runtime. And of course, some of the countermeasure may apply the fact that we need to improve the design of the system, or to introduce new features or develop new pieces of code that will improve the system. And that's why the work package 4 related to protection at development to come after work package 3. So let's start with the first topic of this project, which is vulnerability scanner, and I will let Rosa present this part because they are the expert in this domain. Rosa, are you here? Maybe if Rosa is not here, I will continue.
Wissam, sorry, I was about to find another place to have this conversation with you, but there's no possible. I think there's some noise coming out. Okay, but if you don't, can you hear me properly?
Yes, we do.
Okay, thank you very much. Okay. Yes, as Wissam mentioned, okay, this is about to protect the system while it's in operation, okay, during the maintenance or even when the system is running, okay. And in that case, as Andrei mentioned before, we need to detect vulnerabilities, okay, and this is about, okay, the vulnerability scanner. Okay. First of all, what is a vulnerability? Do you know that? It's a behavior or set of conditions present in a system, in a product, component, or service that violates an implicit or explicit security policy. Okay? And what attackers do? What do attackers do? Attackers exploit vulnerabilities to compromise confidentiality, integrity, availability, or any other security property, okay? And maybe you are aware of it, but vulnerability, okay, and normally are with a identifier, which is called common vulnerability and exposure number, okay? And that means that the vulnerability is publicly known, okay? And there's a list, okay, with those vulnerabilities, okay? This list, okay, is done by Mitre, okay? And you've got a link there, okay? But there are many other bases for vulnerability data sources, okay? Not only okay, the main list is the CVE list, okay, but some others can use that list, okay, like the National Vulnerability Database, NVD, or many others that you've got there, okay? So, yeah. So, in this case, vulnerability scanning or detection can be done in different ways. Manually, you can look for vulnerabilities every day or even an hour, okay? You can make them automatically or combining both techniques, okay? And can be passive or active. Active means that you infer some traffic, okay? And you bother the system somehow. And passive is like you look for some not normal behavior, but in a passive way, don't bother the system. Okay, and we've got different system tools for web applications and for the IT world, okay? But not so many for the industrial systems. And as Andres mentioned before, industrial systems have got vulnerabilities, okay? And that's critical because normally these are considered severe or with high impact vulnerabilities. So we need to protect the systems, okay? So many of those applications, okay, do not support industrial protocols like OPC UA or any other industrial protocol that you may think of, okay? So they don't detect even the presence of a target, okay? These systems sometimes are connected directly to the system, and sometimes the industrial system cannot be connected to the scanner, okay? And scanning tools are mainly for IT environments, but sometimes they are not applied for the operation technology environments. In this project, in VeriDevOps project, okay, we propose to design and develop a tool called the Threat Oracle Engine, okay, that will make use of the common platform enumeration identifiers, okay? These identifiers identify hardware and software, okay? So in that sense, we will be able to look not only for the operating system and install applications, as many other vulnerability scanners do, but also to look at open source libraries, packages, cryptographic chips, and so on. Because the main idea of this vulnerability scanner is to be to make use of an asset inventory that is built from the development phases, not at the end, okay? Considering all the software and hardware components that it's made up of, okay? So the idea is that initially, the TOW will use the National Vulnerability Database because it's the most extended one, okay? But this vulnerability scanner can be updated with any other vulnerability data sources, okay? And this is a diagram, okay, that tries to set at a high level design of the vulnerability scanner, of the THOW, okay? And how this system, in the upper bottom, you can see that can be also can have a logging subsystem that can later be connected to a commercial CM, okay, security incidents and event management, okay? And the different databases that are specifically separated in case of an accident, in case of something happens with a database or anything, okay? This is the main idea. Everything is separated to make it resilient from the beginning. Can you go to the other slide, please?
Yeah, so I'll continue, Rosa. Thanks a lot. So these vulnerabilities can be exploited by attackers. So it's crucial to monitor the security of the system at runtime to be able to detect intrusion or detect anomalies. So the idea of security monitoring is either to have a set of signatures, attack signatures or attack patterns that are already known. So in this case, we can apply some rule-based detection to be able to detect these attacks. And for 0 days attacks, that means the attacks that are not known, so we don't know yet their signatures, we are obliged to perform other kind of detection. And in general, we apply some machine learning or artificial intelligence algorithm that will allow to detect these kind of attacks. But let's start from the beginning. To be able to monitor a system, we need to collect data and capture this data. Of course, in IT system, we can have some specific monitor to collect network traces, for example, based on some TCP dump or libpickup or DPTK libraries. We can also see the system logs. We can also access to some application logs. But in industrial control system, sometimes it's not as easy as that to collect this kind of data. And of course, in this industrial systems, they also use some specific generate some specific protocols. So we need to have tools that are able to extract this this protocol and to extract the different fields and understand the meaning of these fields to be able to perform correctly the monitoring of this data. And of course, when the system is distributed, we need to also determine where to deploy our monitoring agent to be able to have a global overview about all what is happening on in the system at different layers. So the infrastructure layer, the hardware layer, the network layer, the application layer, etc., which is very important to be able to have monitoring in depth of this ICS system. Let's take now the specific challenges related to rule-based detection. So we can, when we speak about rule-based, that means that we are specifying or we are modeling the attacks using a specific grammar. So this grammar we need to study its expressivity, because we would like to be able to express all the attacks, all their details. And if we have complex attacks that may involve several data sources, that may involve also the correlation between different events, this should be possible. And of course, if the expressivity of this model is not enough, we'll miss for sure several kinds of attacks, and that will not be possible to be detected using our solution. Another challenge is the fact that in ICT system, but also in ICS system, industrial control system, the vulnerabilities are always discovered. So we have always new vulnerabilities, new attacks. So we need always to update the database of signatures so that we don't miss any new kind of attacks. And of course, you know now that all the communication is in general encrypted, and this will give a big challenge to the monitors that maybe mainly the network monitor that will have only encrypted data, and in this case it will be more difficult in general to detect attacks for encrypted data. For the anomaly detection challenges, of course, in general, we use some machine learning techniques with the idea is to draw a baseline of the normal behavior of your system, and then to detect any deviation from this baseline or this model that we are learning. Of course, we can use several type of algorithms that can be supervised algorithm or unsupervised algorithm, but in general, the most important two things are related to the accuracy, in the sense that we need to minimize the rate of false positive and false negative, but we would like also to have near real-time detection. It's sometimes it's not very let's say it's very important. It's very important to have an alert or to raise this alert as soon as possible. If we have the alert in 1 hour or 2 hours to say yeah, 1 hour ago there was an attack, maybe the impact will be very high on the system. So the idea, and since we know that this type of algorithms are in general time consuming, so the idea is to minimize their detection time. Of course, we can all have other challenges that are related to detection in general, mainly when we have a lot of data that is collected, mainly if we are dealing also with high-speed networks where the data throughput is high. So we can consider ourselves sometimes in a big data context, and in this case, maybe we should apply also different technologies that are adapted to this big data challenge. Here, I give some example of network intrusion detection system like Snort, Suricata, or Zeek. I don't know if you know the Zeek. It's the new name of the Bro IDS, but in fact, our solution that will be proposed in VeriDevOps will be based, or at least will try to tackle all these challenges, and it will be an adaptation of an existing tool of Montimage called MMT, Montimage Monitoring Tool, that is already able to analyze different kind of data. So it can be some syslogs, some network traffic, some application logs. This is possible because our extraction engine have a plugin architecture that allow to analyze any kind of information and transform this information into a set of events that have the same format, which is a key value structure. So so all the information that can come from different sources will be transformed in the same format that can be the input of our correlation engine that will allow to correlate the different events and to check properties that can be functional, security, or performance. But in the context of VeriDevOps, will mainly work on security properties, and this security property can either model security requirement or malicious behavior. So we can model the good behavior. So if this good behavior is violated, we raise an alert, and we can also model the bad behavior. So if we detect this bad behavior, we'll also raise an alert. And in the tool itself, we are also would like also to apply some machine learning techniques. We already did that in IT environment, but now we need to do it in the context of industrial environment. Maybe we will use some kind of clustering or Bayesian network, or even some neural networks, depending on what we have as challenges related to the case studies. When we raise an alert, sometimes it's not easy to know what is the origin of the problem. That's why mainly when we apply some anomaly detection, we know that there is an anomaly, but we need to check if it is first of all a false positive or not, and then we need to determine the origin of this alert. So that's why we use root cause analysis, which is a method for identifying the root causes of observed incident and problems, and it is applied in general in a wide range of domains, including IT, system, telecommunication, industry, transport, etc., etc. So the idea by applying root cause analysis is to be able to select the best countermeasure that will mitigate the damage of the problem. So in general, there are three key ingredient to be able to perform successful root cause analysis: the domain knowledge, the system knowledge, and the observations. The domain knowledge is that these are the laws that govern the system. For example, the law of mechanics for a mechanical device. The system knowledge is the element that compromise the system and the relationship. So we need to understand the relations between all the different components of the system, their relative position, their interfaces, etc., etc., and the observation, because as you know, not all the events can be observable or can be captured. So we need to work on the observable data coming from the system. For example, for a printer, we can see the printed pages for a printer, or the information from its internal monitoring sensors, etc., etc. So all these information are important to build the root cause analysis, and to will allow making inference on what could be happening in the unobserved part of the system, and predict future observation and potentially solve the root cause analysis problem. Here, in the context of VeriDevOps, we'll use the root cause analysis tool of Multimage that will rely on some similarity learning to be able to identify the probability of root causes and provide accurate recommendation about the most adapted corrective action to mitigate the risk. The big challenges here is, first of all, to have a learning data set from previous incidents and their causes. And the second challenge is also to determine what are the metrics, what are the metadata that are the most impacting in a system, to be able to capture them and to work on them. Once we know what is the cause, the idea is to apply some recommendations and some to apply some corrective actions. In fact, in the context of industrial control system, there is some standards that set already some measures for securing ICS system. So we have the SP 882, which is related to, if I remember well, to NIST. So it's a special publication published by NIST and provide recommended security countermeasures to mitigate associated risk in industrial control system. And we have also the IEEC 63069 and 62443 that also specify this and address incident response to ICS system. The problem is that there is a lack of information on how to deploy this countermeasure in a running industrial control system. Of course, these measures will include some software patching or some control power off or some deactivation of certain function or part of the system. It can be also the implementation of some organizational procedure or measure, or use of some compensating mechanism, such as new security function or capability. They can even go further than that and propose to change the system design or architecture, or to develop new feature and integrate them. But the problem is that there is a lack on how to do that. That's why in the context of VeriDevOps, we are planning to build a catalog for resilience enabler that can bring decision support in ICS system under incidents. We are almost at the end of the presentation. Here we present some potential innovation related to all these features for the vulnerability scanner, as said by Rosa. In her talk, there is a lot of scanners that are mainly for web application or IT system, but not for industrial systems. So we would like to build, in the context of VeriDevOps, a vulnerability scanner for industrial system that will address both hardware and software vulnerabilities, and which will be based on some defined CPE-based access inventory, and will and the configuration issues will be covered by the standard called SCAP. For the intrusion and detection and anomaly detection, of course, there is a lot of solution for our IT system, but there is not many solutions that will correlate data that is coming from different layers and will maybe be able to link the physical layer with the cyber layer, so and detect more complex events. So this is something that we would like to do in the context of VeriDevOps, and in general also the intrusion detection system focus on the detection of malicious behavior. So they don't really work on assessing the security requirements. So we would like to work to support security requirement analysis and also malicious behavior analysis. And we will use some rule-based and some machine learning based analysis, since we know that is very important in many cases to analyze some encrypted traffic or some data, some zero days attacks. We'd like also to have some adaptive analysis in the sense that our monitor should be let's say energy aware, and we would like to only analyze the what need to be analyzed at specific time. So if we detect some vulnerabilities, we will only activate the attacks detection that can exploit these vulnerabilities, and we can of course add new detection properties if new vulnerabilities are detected using the vulnerability scanner. And in the same way, when we are in a, let's say, a specific attack context, maybe we should trigger the monitoring of more detailed data and the extraction of more metadata to help us to make the diagnosis and to determine the root cause analysis of the problems. For the reaction, so as I told you previously, there is a lack of information how to deploy countermeasures. That's why we rely on the root cause analysis to have the best reaction to be performed according to the origin of any incident, and we rely on a catalog of resilience enabler to ease the deployment and configuration of these enablers for specific contexts. And this is all for my presentation. I don't know if you have questions. I think that we have I have a question from Fu Nguyen from Sintef. Hi.
Yes, hi Wissam.
Hi.
Hi everyone. Yeah, thanks a lot for your presentation, Wissam. So it's me, Fu from Sintef. So I think yeah, I like very much this direction, and recently yeah, at Sintef we have done a systematic mapping study on the approaches for using let's say AI supported security risk assessment.
Mm-hmm.
And I think that our finding is very much aligned also with what you're presenting here. So basically the AI supported security risk assessment has been increasing quite a lot since the last decade.
Mm-hmm.
I think it's the focus so far has been mainly still focused on the intrusion detection. So basically on the risk identification. And maybe a little bit on the risk estimation, but I think the one thing is very still very lacking or not yet research on is about risk assessment, or no, risk evaluation, right? So it can give some kind of whether the risk or its magnitude is acceptable or tolerable, and then we can base if we have the risk evaluation that can be supported somehow by AI or machine learning, then it can provide some input for the decision about risk treatment.
Yes.
So I see it's quite aligned. But I think I like the point that you mentioned about the catalog part, because I guess if it not, of course, it's really not possible. Like you can use machine learning for providing suggestion for risk treatment for everything. But so it means there could be some that can be supported by AI, but then for example, like if you have to redesign the system and so on, it is not possible. So
it's still a challenging task. I think it's still a research topic, this AI supported risk assessment and management. I don't know if you have already some publication in this way.
The paper just got accepted at ComSac, so we can I think it will be published soon, hopefully. Okay. But I think if first of all, I don't know if in your catalog you may have some direction for what kind of treatment that may be possible to be supported by AI and what is not, right? So I think that could be one.
It's something that we need to study. Of course, we are still in the beginning of the project, and the idea is that we would like to rely on the already the measures that are mentioned in the several standards that we identified, and maybe some of them will focus on this AI part, and I'll let you know when we have further result on that. Today it's not.
Okay, sure. I think of course we will keep in touch and.
Sure.
Okay, thanks.
Wissam. Thank you a lot.
Wissam, can I say something? Yes, I think it's very interesting what you propose. Fu, what's the name? Fu?
Yes, yeah.
Okay, so I think it's really nice what you said, because I think it is true that you can find a risk or a vulnerability in a system. Imagine that we have built a system with some kind of hardware and software, but imagine that you use an open source library like Embed TLS, okay? Mm-hmm. And you find a vulnerability there. There's a new vulnerability with the thaw, okay? We look every minute if there's any new vulnerability, okay, for that library. And we found a new vulnerability. But that vulnerability is related to something else that you don't use in your system. Mm-hmm. So there's no risk at all, okay?
Yeah.
But imagine that you find that vulnerability, yes, it is core for your service, okay? So in that case, we need to pay attention to that, okay? We need to measure the severity, and we need to decide what mitigation we need for that.
Yes.
And I think we will work on that.
Okay, yeah. Yeah,
Thank you.
Thanks, Rosa. I think it's, I totally agree. And it is very much with the, let's say, the risk assessment flow, then if we can make the connection between the identification until the risk evaluation, that provide the input for the treatment reaction part. So that is, and if whatever can be supported by machine learning, maybe we can figure out during the, with more study, but yeah. Okay, thanks.
Yeah, but between us, Fu is the coordinator of the ENACT project, H2020 ENACT project that finished this month.
Yeah, that's our team. So we have Nicola and Hui and a big so it's a group, but our group is a coordinator for that project. So it's very nice collaboration that we have in that project, and hopefully we can bring in more the DevOps perspective to the next project as well.
Okay, nice meeting you then.
Yeah, very nice to meet you. Yeah, thanks.
Thank you a lot. Thank you a lot. I will stop sharing because I think that we are out of time, and I will let the floor to my colleague Dragos.
Okay, Tanvir, Dragos, Eduard, please.
Yes, I think it's Edward that will start.
Yeah, but Tanvir, is it possible for you to share the screen? So how are we doing with time? How much time should we spend on work
we
package?
overlap, but I guess it's since it's kind of home event, we can do your best, and then it will
okay.
time from discussions.
Good. So okay, but let's start. Thanks, Tanvir. So so I'm Eduard Denoyo. I'm a senior lecturer at Mälardalen University in Sweden, and I work with software testing and applied formal verification. And together with Tanvir Ahmad from Obo Academy, we'd like to outline here a part of the state of the art related to the technologies used for ensuring some security aspects at the development phase. So we will specifically look into how formal specification developed in other work packages can be used for automated test generation, security testing, and vulnerability localization, for example. And we'll focus on those technologies that are reported in the state of the art. Next. So today, Tanvir and I will try to cover the following subjects, spanning from formal analysis and verification to security testing and localization and debugging. Next. So getting back to the VeriDevOps concept, this state of the art relates to the development part. So you see that in green, where designs need to be checked. Then you have automated tests that need to be generated and executed. So that's the focus of this short presentation we'll give today. Next. Good. So from a technology point of view, we're looking at how to also combine model-based analysis and verification with test case generation for testing of large-scale industrial systems. So, of course, this is not easy to do, especially if you do security testing, and there are some prerequisites to even start working on this. So first, there needs to be like some type of extraction, automated or semi-automated, of relevant security information from assessments or from security requirements. And I think my colleagues explained this in some detail before. And then you need some type of analysis, for example, model checking of the resulting model or anti-model. And the idea would be to have a test case generation where you can automatically create these test cases, execute them based on some type of security test criteria. So the results will be, the results should take the form of a methodology to validate this security functional requirements, but also security non-functional requirements and even safety if that's possible. And the idea is to have full integration of the set of these components. And I'm showing here on the slide the generic process of this. So starting from safety and security requirements to execution of the system under test. Why I'm mentioning both safety and security requirements, because in many cases, safety and security issues are, converging, especially in cyber physical systems. So this leads to, in a way, to a situation in which these two are closely interdependent issues. So should be considered together rather than separately or in sequence. So we should be interested in applying security measures in order to strengthen security, prevent attacks, breaches, but also safety, for instance, like timely completion of hard real-time tasks. So yeah, I think this is the context where we're dealing with and the technologies that we're looking into. And now I'll try to explain where this fits in the prevention of development. So next slide. So security, as you know, it's not a unique feature of the software. So it's important aspect of software that should be implemented in this, every major phase of the software development lifecycle. So there are several processes used to integrate security at various stages of the systems development lifecycle, SDLC. And I think, for example, Microsoft has published a software security process called Security Development Lifecycle. As I mentioned, that introduced security and privacy early throughout all phases of the development process. And another example that I show on the slide is the software assurance maturity model, SAM, framework that comprises of 5 phases. You have the governance phase, design, implementation, verification, and operations. So we will actually describe techniques that are used to enforce security aspects at development in different stages. So I want to outline this model in the beginning, because we introduced security testing and discussed fuzz testing approaches, search-based security testing, model-based testing, penetration testing, and localization and debugging approaches. And all of them fit in a certain space here. Next slide. So formal methods. So we start with that because you saw in the beginning that we had a requirement model that needs to be checked. So we actually looking for logical reasoning from logical or mathematical specification of the behavior. And the idea is that they offer rigorous proofs that all system behaviors meet some desirable property. So for security, if you have crucial for security goals, this is important because they can show that no attack strategy in a class of strategy will cause a system to misbehave. That's important. So you could rule out a whole range of attacks. So they offer, benefits like, for example, if you formal specification will tell an implementer what to produce and they tell the user or integrator what to rely on to do it. So, and the problem is that the many vulnerabilities arise from misunderstanding and mismatch as components are integrated. So the payoff here is that you have rigorous interface specification. And the thing is that the adoption of formal methods in various areas has improved and has gained a lot of momentum, but we anticipate here that formal methods can provide similar improvement in the security of this industrial system. So I think formal methods are in a period of rapid development in broadening this application. So there are many I think in a study, for example, an NSF study on formal methods for security, they actually discussed not only the benefits of using formal methods for security, but they also highlighted several open research challenges. So I would like to mention them here quickly. So the idea is an open challenge is how to provide security guarantees at the system level, as opposed to individual unit level or component level guarantees. So especially in large scale industrial system, that's a challenge. And also what abstractions to use to enable the use of these formal methods for security guarantees. I think that's a challenge in itself. And most importantly, how to standardize existing and new tools that provide this. And how do you support them during the software development lifecycle? And at the end, how do you have industrial scale use of formal methods for providing security? So these challenges, I think we think must be addressed to realize the benefits of formal methods for security, and we will focus on some of these challenges. Next slide. Looking at some approaches, specific approaches, currently there are a few standards for, I think, tools, low-level tools for SAT and SMT solvers, but there are no actually common standards for formal specifications for security, and existing tools actually can vary quite a lot in their representation in specification and proof. So it might require significant effort to combine these formalizations. So, but there have been several, I think, success stories for, I think, whole system security. I think they have something in a DARPA program. Also, I think for verification of a radiation therapy system that it showed quite good results. And so I think there are some approaches for the security. There is also the Descartes agent formal specification language. That's a security framework for formally specifying security requirements. And this can be used to model authentication and authorization requirements, for example. There is also, I think, other tools like I don't mention here, like Tropos or the Datalog, or I think here I mentioned Forvest. That's a tool for formal verification of security specification that helps and guides human verifiers by providing information using the Z notation. So it's actually a web-based environment for using this, for using model checking and theory improving tools. So, and I mean, there are other approaches. I'm not mentioning here everything, so we cannot be, I don't have time to go into other details where the people have done work on security, formal verification, formal analysis for security in real-time system, for example. But I think this is just to give you a glimpse of what work has been done in this area. Next slide. So regarding security testing, this has recently moved beyond, I think, the realm of, you know, scanning the network ports or probing software behavior. And now you actually, you could see, I'm showing here the figure where the software, I mean, security testing has its place in the software development lifecycle. So that's just one part. Once you have the test plans, you can actually start running your security test. And I think it's actually good to notice here that security testing is actually the process of validating, you know, those requirements related to security properties such as confidentiality, integrity, availability, authentication, authorization. And the purpose here is to find weaknesses in the implementation, in the configuration, or the deployment. So there are several literature reviews published on security testing. However, here I'm just discussing one. So the one SLR published by Mahendra and Ahmad, they classified their existing works and their couple of frameworks, couple of techniques, couple of methodologies, and I think even some reviews. And the results actually show that existing approaches for security testing are implemented at various phases of the software development lifecycle, but there is a lack of approaches that can be applied at the design phase. So I think that's one area where I think it will be good to focus also. Next slide. Actually, I want to mention here that there are actually, I mean, security testing must necessarily involve two diverse actually approaches. If you think about it, there is the security functional testing and security vulnerability or penetration testing. So on one side, you have testing of security mechanism that ensure actually that their functionality is properly implemented. And the second one, the vulnerability testing, is performing security testing motivated by understanding and simulating the attacker's approach. So there are two different categories, and most of the approaches will fit in one or the other. And another application of security testing actually is in the context of regression testing, which is interesting for our project. So actually, there is a study that looked at security regression testing approaches, and they actually found 17 approaches, and their classification is based on several criteria like abstraction, security issue, technique, tool support. And what's interesting is that they also identify potential directions for future research. because model-based techniques can be used to increase abstraction and scalability. And there is actually a need for tool support for automated test generation and execution of security tests. So I think that's an area of interest for us. Next slide. So just to mention some different security testing techniques that we found in the state-of-the-art related to the project. So you can actually classify different testing techniques into 4 types. You have model-based security testing based on requirements and design models created during the analysis and design phase, which is an area that I mentioned has not been researched too much compared to the other areas. Then you have code-based testing and static analysis based on the source and bytecode during development. Then you have penetration testing and dynamic analysis, where you're running the system in a test or production environment. And then you have security regression testing that I mentioned, performed during maintenance. Yeah, those are 4 categories of techniques that are interesting. Next slide. So now we'll go in details into some of these techniques. So for example, in model-based security testing, that's an area of research based on model-based testing, which is a black box techniques. And there are actually there's some approaches that work on this, automated test generation and consideration of risk values. And in the literature review by, I think, Michael Felderer, looking at security testing, model-based security testing, they actually identify some system and models that could capture the security requirements. And also they looked at what kind of risk dimension, like how do you specify the risk values. And the idea is that there are few approaches that actually are fully automated, and also having some type of complete model that could be used for security testing. Usually there is a partial covering of those aspects. So at least in this domain, you need to take into account in model-based security testing, you need to look at what's the model of security, system security, the security model of the environment, what's the test selection criterion, and that actually is very different from technique. It depends what are the techniques that you're looking for in security, and also what's the evidence that you provide. So I think that's important also. So more details I think you can find on this state of the art of model-based security testing in the papers that I mentioned, but also you can have a look on our state of the art document. So I hope that will be provided somehow. Okay, Tanvir, do you want to continue?
Yes. Thank you, Edward. So we have conducted a survey on the penetration testing, and it's testing team, which is to audit or rectify the security infrastructure of a system by penetrating or breaking the security mechanism that one have put in place. It is different for functional testing. It's kind in functional testing you are verifying the requirements, but the penetration testing is more like stress testing for a system. There are 3 types of penetration testing. You have network penetration testing, where the tester aims to identify the security flaws in the design and the architecture of the organization network. And in the application penetration testing, tester is looking for vulnerability in the application to implement business logic. So, for example, a web application. In social engineering, the tester audits the workflow of a target organization by targeting the human interaction to gather confidential information regarding the target, which otherwise is supposed to be kept confidential. There are different ways to, different classification has been proposed to categorize the penetration testing. For example, one of them is black box, white box, or gray box penetration testing. So we have noticed that, or it has been different feature that at the moment the penetration testing approach are designed for very specific application domain that are applied to for a very specific to discover very specific vulnerabilities in a system. And there is also a lack of studies or penetration testing approaches for edge computing, such as IoT. And penetration testing approaches which are using models such as Markov decision process to generate attack pattern, they lack scalability and real-time identification of vulnerabilities. So we aim, in this project, we aim to develop new penetration testing approaches which can be used to detect IoT using machine learning and heuristic algorithms. More mutation fuzzy testing, it's a category of software testing technique that is that generate invalid input to the system under test in order to reduce possible flaw vulnerability. We have described several approaches in the deliverable, but here I have mentioned few of them. So in the first one, the authors developed, implemented the security protocol in HLPSL language, and they mutated that model, and with the security on security flaws, they generate this a Vista tool. In the second approach, the authors model the web service in OOPA Automata, and they mute model and did attack traces by emulating those mutants. In the third approach, they use ASLang++ language to build a secure model of a web application, and later on they mutate the model with the vulnerabilities and use checkers CLATSE to generate attack traces for the web application. The other approach generate input data to identify security vulnerability. Fuzzy testing are main types of fuzzy testing. In fuzzing, this is the simplest one. In this one, we generate a random stream of input data and we send to the system on a test to reveal any hidden vulnerability or a bug in the system on test. In mutation-based, it's more sophisticated random. We have knowledge of format or the structure of the input, and we mutate that structure to generate data and send it to the system. In generation-based fuzzing, in this technique, we have a proper understanding of the model, the file format, the specification of the data, and we use to generate more intelligent or more sophisticated stream of inputs to reveal any security flaws. Another technique is this hybrid fuzzing is also known as advanced fuzzing. In this, we combine different approaches with fuzzing. For example, there are approaches that have combined symbolic execution with fuzzing, and there are approaches that have combined learning with the fuzzing to or test system in a more sophisticated manner. We have that in the recent year, there are not approaches that are using model mutation, so there is a still gap. If we compare the number of approaches published for model-based mutation with the code-based mutation, and authors have reported that generating test cases in Oracle is still challenging when we are using mutation-based approaches. And most of the approaches proposed a very limited set of mutation operators to mutate the model. So we aim to develop new model-based mutation and fuzzy testing approaches where we defined more model-based mutation operator to more or of vulnerabilities in the system. And there are different approaches that also uses search-based techniques to find secure flaws in the system under test. There are different approaches. Here I have mentioned 3 of them. So for example, in BioFuzz, they use genetic algorithm to detect vulnerability related to SQL injection. So what they do, they search for the input whose characteristics are close to a triggering attack related to SQL injection. And in the second approach in SE, they are for injection vulnerabilities, but they use a different mechanism for they monitor which inputs to the system under test translate to which SQL statement that are sent to the database. So they are monitoring the communication between the application and the database, and they generate those inputs or search for those inputs that can generate SQL statement that are similar to the non-malicious SQL statement. In SQL injection, XML injection, they use genetic algorithm to generate XML messages that matches non-XML. Approaches that use space testing technique with the large input spaces, and any approaches also this is a Oracle problem when dealing with security. We aim to propose a search-based security testing technique for REST API using metamorphic testing. This allows us to resolve the Oracle problem by creating metamorphic relations of the API, REST API endpoints. Software for localization techniques, the act of identifying the segments or the modules which are responsible for causing the fault or a root cause of the fault. These approaches are used to help developer for debugging after discovering or fault. There are 7 types of localization techniques. In the first one, spectrum-based fault localization technique, we use the code coverage information after running the test suite. The idea is that the more frequently a statement is executed in failed test and the less frequently it is executed in the pass test, the more suspicious the statement would be. And in the mutation fault localization, we consider execution of a affects the result of a test by injecting mutant. And in the mutant, when we're generating a mutant, we usually change one expression or a statement by replacing an operand on an expression. If a program statement affects fail test more frequently and affects the pass test rarely, then it means that this statement might be the root cause of the fault. In dynamic program slicing, we isolate the statements that are executed when we provide a specific input that crashes the program under test. In predicate switching, we fail tests can change pass test, modify evaluated result of predicate. That means that predicate is the root cause of the fault. In information retrieval, we treat a bug report as a query and we rank all the source code file by the relevance to the query. And the more relevant source code file may contain the bug inducing statement. In history-based fault localization, we assume that the source code files which contain more bugs in the past are likely to have more bugs in the future. There are many fault localization techniques that have been published, but for security testing, there are many. For example, there is Lucon, which is using a graph-based localization technique which identify concurrency related bugs. Then we have another approach which uses spectrum-based fault localization to identify those statements which induce cross-site scripting bug. Then we have this fault localization framework, which is based on a single path canonical execution. In this, we can generate numerous test cases based on execution path of one failed test case. And these test cases are then used to find, are used as an input for a fault localization technique to rank which root cause of that part. And in this project, we aim to develop a fault localization technique for our to supplement our model-based mutation testing approaches and penetration testing approaches. to help to speed up the debugging process. As Edward mentioned, the security testing needs to be integrated with your development in configuration. Microsoft has published their this secure development cycle. Basically, is we integrate different security methods and practices at each phase of software development to ensure that we are building a secure software product. Similarly, there is also devs organized software engineering practice, which aim to integrate software and operate. Objective is to build a secure software product by automating, monitoring, applying security at all phases of the software lifecycle. However, there are some problem or concern when we are integrating with the continuous integration. For example, a developer encounter new security concerns or when start working with the continuous integration pipeline, because the CI pipeline needs to have access to the entire source code of your project, and therefore the security and the access controls are very important. And for example, if the company is using CI pipeline as a service from a third party, that can be a issue. Secondly, when we are building a mission critical or defense related software product, there are the knowledge of secure software modules is only few individuals have access to certain modules of software, and if those modules needs to be the part of the CI pipeline, then the information then they need to be explained, and then it's also a challenge that how you make sure that these modules are only visible to certain individual if they are also the part of CI pipeline. Another problem identified in the literature is that in this integration continuous pipeline, additional methods are not well suited for this integration. In this project, we plan to develop an organizational and process model blueprint, which would allow the practitioner to define, model, and execute and test security requirement, which is either very difficult or not entirely possible with the current processes. So overall, we have found there are approaches are verifying security requirements, and there is a lack of software testing techniques for cloud or space computing, such as IoT. The scalability and the abstraction level of the current model-based testing techniques can also be improved. There is a lack of better tool support to generate and execute test cases. And the penetration testing approaches lack scalability and real-time identification of vulnerability. And we hope that in this project, we develop or we could overcome these gaps by developing new software testing approaches using model-based mutation and fuzzy testing by defining new model-based mutation operator for testing the security aspect, and also develop is for testing. Thank you. Any question?
Okay, yes, do you have any questions on this material? Quite a lot of things, I guess, about testing, fast testing, mutation testing. Okay, I guess in this case, since we overlap quite a lot, I guess Dragos can present quickly the wrap up for today's session, and we can switch with a small discussion if anyone have some questions. Hello, Dragos.
Hello, everyone. So I will try to wrap up quickly what the previous presenters have discussed. Hopefully you can still bear with me for some time, even if lunchtime is getting very close. So my name is Dragos Suskan. I'm a senior lecturer at Åbo Akademi University in Finland. And my main interests fall into software testing, model-based testing, functional and non-functional testing. So I hope you can see the screen with the presentation. So basically, I just want to remind you our conceptual approach in VeriDevOps. We start from informal requirements and vulnerability attack and attack descriptions, and we want via NLP to formalize these requirements, especially the security requirements, and then these formal specifications we plan to use for both phases of the DevOps process, either for enforcing the design or generating automatic tests at the development, or for performing automatic anomaly detection or root cause analysis, vulnerability scanning, and so on at operations. And my previous speakers already highlighted different approaches that are already in use, that have been proposed by other researchers and projects. And also they discussed gap analysis, what are kind of the missing links, or what is the need for improvement in those in the current research. And since we didn't provide this link so far, our detailed state-of-the-art report, deliverable 1.3 of the project, can be found from this address. We have a bit of a problem currently with our official website, but then this deliverable will also be available on the official project website. I have placed the link for the deliverable also in the chat of the Zoom, on the Zoom client. Yes, and also I would like to remind you, maybe from the objectives of the VeriDevOps project, that we plan to elaborate a methodology for maximizing automation at different level of DevOps, to provide a tool chain for automated generation of formal specifications from security requirements, to design and develop automated root cause analysis and countermeasure recommendations systems for operation level, operation phase, and to design and develop a tool chain for automated specification and verification of security requirements. And last but not least, to integrate everything into a tool chain, we call it a framework, with that can be applicable and usable in industrial settings. Therefore, kind of the main outcome of this project, we plan to have a model-based formal security framework enhanced by NLP, where and this framework will provide different tool components that can be used either standalone or they can be interconnected into different ways with other components to deploy toolchains. Different components will be provided by different partners, but the main focus based on the project focus will be at industrial control systems. However, some of the solutions will be generic, so we plan that it will be possible to apply them to a wider selection of application domains. In the beginning and during this project, we'll evaluate our proposed solutions against the case study needs, industrial case study needs in the project. And then as soon as we have some evaluated solution, we will release it publicly. There will be several increments throughout the project, and the information will be distributed via public project deliverables. We'll organize different thematic workshops, and also will participate in different dissemination events, conferences, fairs, exhibitions. But briefly about the main features of our toolchain or of our framework. So at the requirements formalization level, we plan to have an NLP-based toolkit developed mainly by Softeam, but in collaboration with the research partners in VeriDevOps, where the goal is to have a larger and cleaner data sets for security requirements, multi-class classification with BERT-like methods, mapping to attack patterns from different databases, and using attack patterns as reusable object-oriented partners, for instance, for testing. Then to enable prevention or proactive prevention and design, we have a handset of solutions. These are initial plans that these solutions will be evaluated, and first on the industrial case studies, and then we'll proceed in more detail with them depending on the initial results and their suitability. But we have, for instance, solutions for using model-based mutation testing for security using formal models, then test generation for PLC systems by extending an existing tool, complete test, combinatorial security testing based on another tool, CFOX. We are going also to investigate how to apply fuzzing in combination with metamorphic testing for stateful REST APIs, and complement these techniques and the other techniques in the project or solutions with fault localization approaches, where we want to highlight code fragments which are likely to cause security bugs. And last but not least, in this topic, a security recommendations catalog. Then, with respect to reactive protection at operations, we have 4 solutions provided by our tool providers. We have a vulnerability scanning solution, which will cope with the main limitation of current tools, that they are only targeted to web applications and general IT systems, but not for industrial control systems. And the new improvements in this tool will address both hardware and software vulnerabilities, and then they will be defined based on the CPE asset inventory. And then we'll have a monitoring tool by Montimage, where it will deploy monitoring solutions at different levels, software, network, and hardware. And it will provide support for industrial control systems. And as presented by Wissam, the idea is to have a rule-based and AI/ML based detection complemented by root cause analysis. Another targeted solution by Montimage is the root cause analyzer that will provide an increased level of automation and better recommendation of corrective actions. And last but not least, from Ikerlan, we plan to have a reaction remediation solution that will be based on a catalog for resilience that can increase the decision support for detecting incidents. So this covers briefly the wrap up for this today's session. If you have any questions at this moment. I guess not. So what is next? And I will give the stage to Andrei. Is that we invite those interested to collaborate on the topics of our project to contact us, and we discuss possible way of exchanging information and establishing collaborations. And then Andrei will like to propose a book chapter, or actually a book, and we are going to call for book chapter contributions to this book.
Okay, thank you, Dragos. So thank you for all coming. So in case you are interested in the topics we presented today, including working with security requirements, with NLP for security requirements, with vulnerabilities, attack, DevOps or SecDevOps. So we are planning to publish our state-of-the-art, let's say, a report as a book, like splitting that in various chapters, and also would like other projects or other teams to join, right? And so we will establish a call for contributions to this book. So we plan to publish it with Springer. The whole process takes about 1 year with them. We will send out a call for contributions for chapters around June. Then if you're interested, we'll gladly accept some topics and abstracts around September. In November, we will ask for chapters. We'll have a couple of months for reviewing everything and like having some iterations. And then around February, we'll finish everything and we'll combine everything in a kind of coherent book. And knowing Springer, we could expect that by June 22, we will have our publication done. So I guess that's a nice opportunity to work together, to exchange ideas, and to report on innovation or any methods and tools that you currently involved in developing. And so would be nice that we can actually collaborate over that. We'll have also some other events based on like progress of our project, and we would like to keep you posted about that. With that, I guess it should I should end. So if you have any questions, please raise your hand or type something in the chat. And I mean, yeah, we'll be very happy to hear back from you, so that we can exchange a bit better. Okay. Yeah. So any questions? Ander, Christina, Damir, Eugene, Gadha, Haris, Massimiliano, sorry, Zainab. Any questions?
I guess everybody's hungry.
Yes. Okay. So then I thank very much you for coming. I thank very much presenters for the material and the lectures. So all the recordings will be available on YouTube. And we hope to hear from you back very soon. Thank you very much for coming, and have a great day.
Thank you. The same.
Thank you.
Thank you to all.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Bye.
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 Bye.